All right, so welcome to May's Miami JS meetup. Today we don't have any announcements, so I'm just going to go ahead and introduce David and Urbano. So David and Urbano are my co-organizers for Miami JS, and David's going to be giving a talk today about building a gaming engine with JavaScript. So David has been working in enterprise and big data, and then he realized that JavaScript was more fun. So go ahead, David.
Cool, thanks, Christina. So I want to do just a quick check, make sure that the streaming is live. I am checking on my phone and I don't see anything yet. But let's see if...
Yep, it's live. It looks good.
It's live. Okay, so I'm going to stop this and we can get started. So let's see, I'm going to share my screen. Sorry, there's going to be a bit of a mess for a second, and hopefully it gets better now. All right, I think it's on. So thanks everyone for joining us. Today is a bit of an experiment because we're trying this new platform. So we're going to be streaming in YouTube. If you have any questions, this is not Zoom, so you cannot talk on the camera or on the mic. But if you have any questions, you can write into the comment sections of YouTube, and then we'll be monitoring that and getting to the questions as they come, or maybe we'll move them to the end of the talk, depending on how we see things are going. So yeah, let's see how this goes. First of all, as Christina said, my name is David Villegas. I'm one of the helpers in organizing this big group that is Miami JS. And this month I'm talking about a project that I've been working on. It's a side project, but it's something that has been on my mind for some time. And I thought it was cool. I got to implement it during the pandemic, or at least implement a close enough proof of concept. So this is the result. This talk is it's a bit all over the place because it's not about a single technology. It's more about different pieces that fit together in certain ways. And I think that the result as a whole is an interesting project, right? And hopefully you can learn from the different parts of it. So let's get started. The name of the talk is Building a Game Engine with Hot Module Replacement. So let's start by saying what the talk is about. I'm going to talk about three main things. The first one is how you can build a game in JavaScript and using web technologies. And if you've been interested in games, you've probably seen that there's a lot of engines already out there, not only for JavaScript. So in many cases, you may want to use Unity or Unreal. There's other ones that are more suited for web, right, and target JavaScript. In our case, we're going to develop an engine from scratch. And the reason for this is, one, we want to learn about the basics. And two, we want to have more flexibility to build it in a certain direction. In this case, this direction is we want the game engine to have this hot module replacement feature embedded into it. It's a very big part of the engine. So that's why we want to have as much control as possible over the engine itself. So in the first part, I'm going to discuss how you can write a game with very simple commands without using a pre-existing engine. The second very important topic in this talk is hot module replacement. And this is a technology that has been around for a long time. If you use Webpack, or for example, you're a front-end developer, there's a very high likelihood that you've used hot module replacement. Sometimes it's abbreviated as HMR. And what it means is basically that your code keeps reloading without having to restart your program. So if you're working on a web page, you can make changes to your JavaScript or your TypeScript, and then there's some process in the background that's going to rebuild all the logic and then inject it into your page without you having to hit refresh. So that's the second part of the talk. And then the final and third part is going to be how do we fit all these ideas together. So first of all, you may be asking, okay, so I get it. You want to write games, you want to write games with this hot module replacement. I get the two technologies, but why? Why do you need to put them together in this way? And I actually got this quote from a developer called Brett Victor from a talk called Inventing on Principle. I think he put it in a very nice way. So he says, creators need an immediate connection to what they create. When you are making something, if you make a change or you make a decision, you need to see the effect of that immediately. There can be any delay and there can be anything hidden. So this idea is something that some people call the feedback loop, right? And what it means is you write something and then you immediately see what's happening, what's the result of your code into a living project that you're writing. This is very important for creators, right? If you're building a game, you're building a web page, you're very interested in the end result. Sometimes there is not just like logic involved, right? There's kind of like a feeling of how it's going, right? In a game, for example, you could be tweaking parameters. What's the gravity of my game? What's the speed of the player? How is the screen or the level designed, right? So it's very important to have this immediate feedback on what you're writing. That's why we want to put this game engine and the hot module replacement, which allows us to load new code without restarting. So let's start with the first part, which is HTML games, or I should say web games, right? Or games with web technologies. So the good news is in JavaScript, writing a pseudo game or a kind of like a simple game is very easy. You just need an HTML element that is called a canvas, and then you just need some JavaScript to access it. A canvas, if you put in your HTML code, it's not going to look like anything. You probably see like an empty square on the screen. But what it allows you to do is, as the name says, you can write things to it. You can draw images, you can draw shapes. And the way that you do that is, if you see here, you just need an access to the element. So you can call get element by ID, like you would do with any other HTML element. And then once you have a reference to the canvas element, you can get a context. And this is the key piece here, because the context is an object that gives you all the functions to draw to the canvas. As you see here, when we ask for a context, we're asking for a 2D context. In web technologies, you can also do 3D, but then it becomes like more complicated because you need to know WebGL, which is a different technology that complicates things a bit more. So that's why we're concentrating on 2D, but all the concepts that we're going to discuss today could apply to 3D games as well. So, okay, so once you have your context, what can you do with it? So for example, you could fill a rectangle of a certain color. So in here, you set a fill style with a hexadecimal color, right? RGB, like you would do for any button or any CSS color, right? And then you can call this fill rect with an X, a Y, a width, and a height. And the result is just a rectangle of that color. Same thing with an arc. So an arc is a bit more of a complex shape where you pass an X, a Y, a radius, a starting angle, and an end angle. So if you want to do a full arc, you would pass 2 pi. This is the reason you pass pi is because the angle is in radians. So it's the same as saying 360 degrees, right? So you can get different shapes using that. And also you can draw images. And one of the nice things about this, and one thing that you'll see again and again, is that we're just reusing technologies that the web already gives us, right? In here, we're using this image object with its constructor. So we can build the image and then assign a source attribute. And then JavaScript will just go and fetch that image from whatever it is. It could be on your same machine, could be on a different server. And then once you have your image created, then you can draw it on the screen. Again, it's an X, a Y, a width, and a height, right? And this is exactly the same call that you would make if you're inserting, for example, an image in your web page on runtime, right? So we're reusing all these functionality. All right, so those were three very simple examples, but they allow you to do a lot of things already. So now let's take a step back and look at how a game would look like from a higher point of view. So in a game, usually you have what we call a game loop, which is an infinite loop that keeps running all the time at a certain frame rate. So in modern games, it would be 60 frames per second, for example. So that means your code would be run once per frame or 60 times per second, right? Or once every 16 milliseconds approximately. So in your game loop, what you would do is you would read the player input. And again, we see a common JavaScript function, right? Add event listener. You can listen for things like key down, key up. You can listen for gamepad events. You can listen for mouse events. And then once you have your input, you would update the game state. And here the game state is just what defines the state of your game world, right? So if you have a character, what's the position of the character? What's its speed? If there's like enemies on the screen, bullets, right? All these things you would store on your game state and you would update based on the input, right? Then once you have a state for your game, you would draw it on the screen using the primitives that we've seen, using the context, right? Usually you would do draw image if your game is based on images. If it's based on geometric shapes, you could use the other ones. And then you wait until the next frame, right? For these, in the old days, we would have to set a timeout, or if you know the function set interval, where you call something like with a certain frequency. But these days, you can call this request animation frame, which kind of tells the browser, hey, let me know when you're ready to refresh the screen with a new frame, right? And then you pass a callback, which would be your same game loop. So then the browser would continuously call your code 60 times per second, and then you would have a game. So that's everything I have to say about building a game. I hope that you got the gist, is that you get a context, there's a canvas object where you draw things on, you can use images, you can use shapes, and that's it. You have this game loop that continuously executes frame by frame. So now that we've seen that, let's talk about the second part of this talk, right, which is hot module replacement. And for this, I'm going to use the words of the Webpack team, which in my opinion is one of the most well-established bundlers there. I mean, I know there's others, right, but they've been around for a long time. They had to implement hot module replacement already. If you use Webpack, I think, so before we had to use what they call the Webpack dev server to get this hot module replacement. These days, I believe you can just pass a parameter like serve or something like that to your Webpack command. But the idea is that, so Webpack, if you haven't used it, is just a bundler with a lot of other functionality that watches your source code. And then once you change a file, it creates a bundle. So it basically puts together all the code and runs some transformations in it. Like you could be writing TypeScript, and then it has to be compiled into JavaScript. Or maybe you want to minify the code, or you want to, I don't know, like bring your CSS inside your JavaScript, which some people do. So basically that it listens for changes in your code, and then it creates bundles. But it has the option of doing it using this hot module replacement. And the way that they explain it is hot module replacement exchanges, adds, or removes modules while the application is running without a full reload. And again, we go back to this closed feedback loop, right? You're working on your web page. You don't want to be pressing reload on the browser every time you make a code change, right? So you want it to happen as you modify the code. So one thing about hot module replacement is it can become very complex. If you look at how Webpack does it, it's an extremely complicated piece of code, in my opinion, because you have to have a lot of things in mind, especially if you want to create a generic hot module replacement engine, right? The problem is you have different modules or packages in JavaScript that could be different files. And then if you change one and you want to update the whole program, you have to have into account what the dependencies between the modules are. So if you modify these, okay, so you have to modify this other module that depended on the first one, and then now this one has to be modified because it depended on this. So you have to create this graph of dependencies. Also, in the case of Webpack, it may be generating different chunks or output files. So you have to decide which ones am I going to update, which ones am I going to notify the client to reload. And especially the hardest problem is maintaining the state. And the problem here is that the state is application dependent. And this is not, by the way, a React state. It could be any, it's a generic term, right? It could be any kind of state. State means what's the application doing at a certain point in time. For example, if you're writing a React application and you have a button that you can click and is a counter, right, and keeps track of how many clicks you've made, then the state is the count of clicks, right? So the question here is, if you have a reload of your code, does the new version of the code remember that you had done 5 clicks? Or does it reset to 0 clicks again and you have to start again, right? Because if you lose the state, then the output is not going to be exactly what you were expecting, right? I mean, this example is very simple, right? Keeping track of the clicks. But the way that your application behaves is going to depend on the state. So maintaining the state is a very important thing. In a game, for example, let's say that you're working on a, I don't know, collision detection algorithm, right? So you have your player and you're in the middle of a level, and then your player hits an enemy, right? But the collision is not yet working well. So you're working on the collision code. You don't want every time you make a change in the code to have to restart the level, take your player to the enemy again, collide with the enemy again, right? You want it to remember the state. Like your player was in this position, it was about to collide with an enemy. So run that again with this new logic, and then see if the behavior has changed, right? So maintaining the state in a generic fashion is very difficult because state can mean many different things. But if we do what we're doing here, where we're building an engine for a very concrete case, then it's not that difficult. We can take some shortcuts, and we'll talk about that. So in reality, changing the state of a JavaScript program is relatively simple. And I'm going to show you how you can do that, right? In a very simple example. So what I'm going to do is I'm not even going to open my editor. I'm going to do this in the Google console. But let's imagine something, okay? So let's say you want to define a function. Let's call it say hello, right? I'm going to do it as an arrow function to save space. But let's say that your function, the only thing it does is it says hello, okay? So we're defining a function, it's called say hello, and every time it's called, it's going to print on the screen hello, right? So if we call say hello, we get hello, the string. So far, so good. So now let's imagine that we have some code that's external to our function that's going to call our function. And let's try to replicate a game loop. So we're going to create an infinite loop. So set interval, if you haven't used it, is similar to set timeout. It executes some code. But the difference with set timeout is it does it continuously every certain time, right? So what we're going to do here is we're going to call say hello every 3 seconds. So 3,000 milliseconds, right? So now we have a function, say hello, and then we have a loop, right, that keeps calling our function. So every 3 seconds, we say hello on the screen. So what I want to show you here is how easy it is in JavaScript to redefine your code as it is running, because JavaScript, as we know, is a very dynamic programming language, right? So I could do say hello is going to print howdy instead of hello, right? So look at it. I'm just changing how say hello works, right? I'm not changing the main loop code. But since say hello now points to a different function definition, our loop, right, this loop that we put here is oblivious to what say hello does. The only thing it does is call say hello. So this is an example of hot module replacement, if you want to call it hot function replacement, right? Because we're replacing the function. And actually you can do even more interesting things, like what happens if say hello depends on a global variable. And so now say hello is going to print whatever is stored in the greeting variable. Obviously, we haven't defined greeting yet, so now we have an error. But what if we change the value of the variable now? So it doesn't work. Very good. Oh, because I have a sorry. So there's a there you go. It was a double quote. So you see, we changed the variable. And now we have two levels of interaction, right? So our say hello is looking for the value of our greeting variable, right? Which right now is Hola Miami JS. And our first loop is just using say hello, which has all this code where it prints whatever's on the variable, right? So this is an example of how you can very easily change the behavior of your JavaScript program in a dynamic way, right? You don't need to recompile things. You don't need to use external libraries. It's just built into the language, right? Good. So I hope that gave you an idea of what I mean when I say hot module replacement and how it can be built, right? In our example, we're gonna do something a bit more complicated because we're not just using the Google console. So let's talk about what we want to do. So what we want to do is we want to modify our source files. Okay, so this is us. We're a developer. We're modifying source files, right? And we want that to be immediately reflected on the browser. So as you see here in our architecture, we're going to split things into a server and a client. Why do we do that? So the reason is your client, which runs in a browser, right? It's your game. It doesn't have access to your files because of security, right? If your browser could like peek into your file system and see what's going on with the file, that would be a huge security hole, right? So what we need to do is we need a helper here, this server, that's gonna do the file watching, right? It's gonna just monitor changes in these files. This server is basically a web server that could be written in any language. In our case, we write it in Node, and I actually didn't even use Express. It could be Express server. I think I use a HTTP server. And what's going to happen is the server is going to be looking at these files that we changed. The server is obviously on your machine, or at least in the same machine where you have the source code, right? Because you're modifying the source code in VS Code or in your editor of choice, right? So the server looks at those files. When it detects a change, it tells the client, hey, there's been a code change, right? And now the client is not yet going to receive the code, right? Because you from a server, you cannot push, like you cannot inject code into a client, into a browser, right? That would be also a security problem, right? If your server could decide to inject some new code. So the only thing it can do is it can tell it, look, there's been a change in our files. Please update your code with the new change. So now the client can get this new code using a function that we all have used a lot, right? I suppose, which is import, right? In Node, it will be more like require, but in JavaScript, this is what you use to import external modules, right? One thing here is this import is not going to be the one that you write at the top of your file, right? Which is a static import. This is what we call a dynamic import because it happens dynamically in your code, right? So when the client receives a notification that the code has changed, then it has to go to the server, grab the new code, parse it as JavaScript, right? Interpret it, and then include it into the running game. So that's how we want to, well, actually the last step is the client swaps the code, as we did in our example with say hello, right? You swap the function to point to a new implementation. So that, as we saw, ends up in your browser running a different code, right? So that's what gives you a hot module replacement. There is also another small but here, right? In Webpack and in some of these more complex hot module replacement engines, you can do changes in a very fine-grained way, right? You can modify module one, and then the server is going to detect the dependencies between modules, decide what to change, decide what to update on the client. But that's very difficult. So here we take the brute force approach. What we're doing is, if something changes in any of your code files, because you could have a structure of modules, right? You import them inside your game code. But if there's any single change in any of your files, we're just going to bundle everything together as one output file and then send that to the client every time. So we don't care what has changed. It could be a very small line in one of your modules. It could be you added a new whole module. The server doesn't care. It just bundles everything as one JavaScript file and sends it to the client, or tells the client to load it. So let me show you this from a different perspective. This is, again, another loop that we're going to run infinitely while your program is running, but this relates more to the hot module replacement, right? So it's more or less the steps that we've talked about with some technologies that we use. So your server is going to listen for file changes. And for this, we can use some node libraries. Chokidar is a very common one. Watchman from Facebook. And what they do is just that. You register a listener for certain files or a directory, and then these libraries are going to tell you, hey, there's been a change, right? Then once the server knows that there's been a new change, it's just going to bundle everything together into one single file so that the client can just import that file. And for this, we use kind of like a secret weapon, which is ESBuild. I don't know if you know about this, but it's been kind of like a recent technology out there that has enabled a lot of new technology. So if you've heard about Snowpack or Vite, which are new bundlers that are very fast and very interactive, under the hood, most of them, they use ESBuild. ESBuild is just a bundler, does the same as well, it does a part of what Webpack does, of getting a lot of JavaScript files, resolving the dependencies, and building one single file with all the code and exports. But what ESBuild does very well is it's super fast. So here there's a graph that I took from the ESBuild webpage. It's a benchmark. And I mean, it doesn't matter what they are really benchmarking, but you can see the orders of magnitude by which it's faster than other things, right? Like something that in Webpack 5 takes almost a minute, in ESBuild takes 37 milliseconds, right? So it's 370 milliseconds. It's less than half a second, right? So it's I don't care that much about the speed, but it's orders of magnitude faster than other tools. And if we're building something that's very interactive and has to react very quickly to changes, this is a great tool to use. Then the server has built a new bundle, right, with the new changes that you put into your code. So now it just needs to notify the client. And for this, I use WebSockets. There's other technologies, but WebSockets is a good way of sending a message very quickly from the server to the client without having to do the trip starting from the client, right? And finally, what we said before, import this single file that we have bundled with ESBuild, and then replace it, swap it, as we saw with the say hello example. So that's the loop of our hot module replacement section of the code, right? So I think this ends the hot module replacement section, and I think it's a good time to check on the comments. I don't see anything yet, but if you have questions, it's a good time to ask. We're halfway through the talk, so it's good that you ask if you didn't understand anything about how we're gonna put the game together, or how the hot module replacement loop works, because we're gonna see how those things now make sense, one with the other, right? But in summary, that's what we had so far. So those two main ideas: we build a game, we keep a state, we update the state in an infinite loop, frame by frame, and at the same time we monitor for file changes. And when something has changed, we bundle the new code for the game and send it to the client, to the browser, so that it can swap the logic very quickly. So okay, let's move to the third part of the talk. So okay, so we have talked about many things, but now we're gonna take also some steps back and simplify some things and make some assumptions, right? This is not exactly how it works in the final implementation of what I did, but it's close enough so that you'll get a good idea, right? So when we said that your client is going to receive the new version of the game as a bundle, we didn't say what it was actually reloading, because importing a JavaScript file. Oh, I see a question now. Hi, Guido. So Guido's asking, how does the swapping work? So in the example I said before, you can swap a function by just assigning a different value to the same name, to the same variable, right? So in the say hello example, right, you have the say hello definition, right? You put a body and implementation in there, and then at any point in time you can assign a different function to your say hello, right? And that will take care of swapping things, because in JavaScript, whoever is calling the code is just going to call say hello without caring about how it's implemented. Now, in our game, and that's actually a good question, because that's where I was going. What is it that we swap? The question is, I mean, you have a whole game going, right? So what it is that we can swap so that we modify the behavior of the game. So we're going to simplify, and actually this is close to how we did it. And we're going to assume that there is this function called drawGame, right? That you, as a developer of the game, so you have to separate what the engine is. The engine is all the part where you watch for file changes, notify the client, get the canvas, do the setup for the HTML, run the loop, right? That's the engine. And then there is a part of the user of the engine, the person developing a game, right? So from that perspective, if you're writing a game, you just need to write this function, drawGame. And what drawGame does is it's going to get a context that, as we saw, you can use to draw things on the screen. It's going to get an input from the user, like which keys are pressed at that frame, right? It could be like right key is pressed, jump key is pressed, etc. And then you're going to get the state of the world in that particular frame, right? And then your job as a user of the engine, right, is implement this function, drawGame, that will take the state of the game, like the state, again, could be the position of your player, the position of the enemies, whether you're jumping or not, right? Take the input and then update the state, right? For example, if your position is X equal to 100, and then the right key is pressed, then we're going to update the X position to be 110, like move the player 10 pixels to the right, right? So that's one thing you have to do in drawGame. You just modify the state of the world, and then you use the context to actually draw that frame, right? Like based on the state, you know where to draw the images, the sprites, the whole frame in the game. So just that's the only thing you have to implement as a user of the engine. And what's the benefit of this? The benefit of this is that first, the input, the state, and the context, which is what you need to draw, are decoupled from your logic. So when you implement the game, you don't keep the state for yourself. You just get it from the engine. The engine is going to pass the state to you. And what that allows us to do is, since the engine is the owner of the state, you can switch the drawGame function, right? By swapping it, as we did with say hello. We can swap drawGame with a new drawGame implementation, but the state hasn't changed because the engine is the one that holds it. So the engine will give the state to the new version of draw game. And that way you can change the logic of the game while keeping the state of the world. And you'll see that in a demo later, so I hope it will make more sense. But basically, if we assume that there is this draw game, we can assume that the engine is going to do all these other things for us, right? So the engine is going to get a reference to the canvas, it's going to get a reference to the context, it's going to take care of swapping the draw game function with this, like it's going to check, is there a new version of the code? If there is, do a dynamic import from the server, get the new bundle, and then do the swap. And Guido, this is how you do the swap here. It's as easy as a variable assignment. You have a draw game that was pointing to a function before. So once you import the new code, you just need to assign the new draw game that you got from the module into your draw game, right? Exactly the same thing with say hello, right? And now, once you have the updated draw game, then you just call it, right? And again, the input and the state come from the outside, right? The implementer of the game does not decide what the state is going to be. It comes from the engine, right? The engine is going to pass it to the game. So then the game has to obviously update the state and then give it back to the engine so that the engine can keep it for the next frame, right? And then finally, we just the engine is also going to wait for the next frame, right? So it's going to keep these 60 frames per second going on and on. So you as a developer just need to have this draw game. This is another diagram that's going to show exactly the same I've said all this time, but hopefully from a different perspective. So again, we have two main components, a server and a client. The server is an HTTP web server, right? It serves assets, it serves the code, it serves the HTML. So the client is on the browser, is going to grab all these assets and code and JavaScript, then initialize the engine, and then start running this loop with this draw function, right? And then, so as it's drawing frame by frame, right? We have this other loop on the server that's watching for file changes, rebuilding the game code, which, as we said, just has this draw game function, which is the important function. And then once there's been a change, it sends it to the client, which will update it if necessary and keep running the loop at 60 frames per second. Okay. So I think that this is all the theory. Sorry if we went all over the place. But this is actually, if you understand this slide, you understand everything, right? So this is the whole architecture of our engine, how things happen on the server, on the client, how the game keeps running, and how things are swapped on the fly. So if there's any other question, this is also a good point to make it, because now I'm going to talk a bit more before we get onto the demo. We're almost there. So here I just want to mention a couple of things, because we've gone through all this work to get this engine in place, all these components talking to each other and doing different things. But now we get to the cherry on top, right? I mean, we have a whole engine that does this hot module replacement if we've done it right. So now, once we have that engine, what else can we do on top of it, right? And it turns out there's a lot of cool things that you can do on top of this engine. First of all, why stopping at code reload? Why only reloading your code? So if you remember from my draw image example, right? We're just assigning a source attribute to your images, right? It's an asset. So what stops us from assigning a different source attribute to our images and reloading our images on the fly as well? Because every time you assign a new value to source, JavaScript is going to go and grab the new image from the server. So what this gives us is we can implement hot asset replacement, just building on top of the things we have, right? So now our server is not just going to watch for code changes, it can also watch for asset changes. So you can modify the look of your game. Like if you had an artist that's working on Photoshop, you can have your images updating as you play the game, which is also very immediate feedback, right? Here's another very cool thing. So if you saw, we're passing draw game a context for drawing on the screen, the user input and the state. And the engine is the one in charge of grabbing the input by using those add event listener and everything and passing it to you, the game maker, right? But you as the person implementing draw game, you don't know where this input comes from. It could come from a keyboard or from a mouse, but what if we are recording past input and then the engine is feeding you past input instead of the input that the user is entering? So you could replay parts of your game automatically in a loop, which you'll see now in the demo, right? So what I'm saying here is input is controlled by the engine. The engine is going to give you the input. So the engine can pass you whatever it wants, right? As an input, it can fake the user input, and then you can get all this additional behavior. And the final thing is, another thing that the engine controls is how often the draw game is called. So I said the engine is going to make sure that your draw game function is called 60 times per second, right? So that you get a smooth game. But there's nothing that says that the engine could call your draw game less often. So you get automatic slow motion or even frame by frame, so that you can see a frame at a time and then debug a single frame of the game, right? And one thing that I found out is this frame by frame execution plus the browser developer tools is a super powerful thing, right? Because you can execute a frame of the game and then set your breakpoints in your code and then go to the breakpoints and see exactly what was the state of your game at that frame without having to like run around and having to get things in place, right? So that's all I had to say. And now we move into more interesting things, hopefully. So let's do that. So I'm going to, let's see if I can switch. There you go. So I'm going to increase this a bit. Let's see, so. There you go. So I'm going to show you this. We're going to have a browser screen here where we're going to have our game running. We have a console and we have our editor, right? So the first thing I want to show you is when I developed this module, because this is a real library that you can download from NPM. It's actually called Game Sandbox. That's the name of the library. And actually have the links at the end of the slide. So if you're interested, you can download it and play with it. Warning, I mean, it's a very alpha quality thing. It's just a proof of concept. But so one thing that I had to do once I saw that some parts became a bit complicated is I wrote some scripts so that you don't have to do all the boilerplate. So what you can do is you can run with npx, you can do game sandbox init, and then let's call this demo. So this is gonna initialize a project using this engine, right? So what this does is it creates this demo project with some source files and then a game index, right? So we can install all the dependencies. And then let's see what we got here. So what this generated is an HTML page, right? And the only interesting part here is this run game that we get from the Game Sandbox module, right? So here we're importing from Game Sandbox, and we just call run game and the name of the module that we're gonna start with. We set the size of the screen, and this index references an index file, which is your actual game. So if you were developing a game, you would put it here. And as you'll see here, the names are slightly different. So what we called before draw game, I'm calling it draw here. but it's the same idea, right? I'm going to, so now I am not, this is not the engine code, right? This is the user's code, right? Like the game developer's code. I'm using the engine, right? I want to write a game. So I just need to provide a draw function that takes a state, it takes a context. In this case, we don't take an input, just a width, height, and a delta, which is the milliseconds since the last frame. And then we can run all our code. So let's see how this works. So as part of the code of the project generation, we have this watch action that we can run. That what it does is it runs this server that I showed you on the presentation, right? It's this server that is gonna keep looking at these files, right? Detecting that there's been a change, and then telling the client, which is we're gonna run in the browser, that something has changed, right? So this is the basic game that comes when you run the code, right? It's a bit choppy. I may have to switch to Firefox because Chrome is doing weird things. Let's see if we can do it. But so basically what's happening here is you have a game that's running a loop, and that's executing our draw function frame by frame, okay, at 60 frames per second. Here we have the server. This is the server output, right? So it has one client. This is the WebSockets that we talked about, right? So the browser is the client, and it connected to the server, right? So what we can do is we can change our code here. So let's say we want to change the color of our ball, right? So there's this color variable that is used here. You see, we call arc, as I showed you before, to draw a circle, and it uses the color as the fill style. So we can set it to orange, for example. So the moment I hit save, you see the ball changes immediately. So what has happened? The server detected that the file has been modified because I changed that variable. It called esbuild to build a bundle, and then it sent this WebSocket message to the browser. Then the browser did an import of the new code. So as we said before, we don't care about small changes because esbuild is going to bundle everything together and send everything. So all global variables are also interpreted, right? So here we can make any change, right? I could change the background, and then I could even change the logic, right? So let's say we have a radius that is 20. That's part of our state. So what happens if we modify the radius? So let's say, so the radius is going to increase by, let's say if we're going, so dx is the direction, right? The speed. So if it's more than 0, it means the ball is going to the right. So in this case, if it's more than this, we're gonna increase it by 0.1, the radius. If it's going to the left, we're gonna decrease it by 0.1, right? So we make the change, and then we break everything, of course. Oh, because dx is we have to use a state. It's part of the. So one thing of the end, if you have an error, you do have to reload. So yeah, that is still something I'm working on. But you see, we've made a code change here, right? So if we say like, okay, I don't like this thing, let's keep it at whatever it is. And as you see, the radius of the ball is going to stay at whatever it was. The state is not overwritten, right? So we're just modifying the logic, right? But the code is just updating as we change things, right? So that's the idea. Let's see if I had something else. Yeah, that's all I wanted to show you for this demo, right? And I have one that is a bit more complicated. So if there's any question, now is a good point also to ask them how this works. But basically, if you were developing a game using this engine, this is all your game code. This is all you would write, right? You set a background of light blue, fill rect for the whole screen, define the speed based on the time it's passed from the previous frame, update the X and the Y based on the speed, and then recalculate the direction and draw the circle, right? And very important, you return the state of the new state after you have applied all the changes, right? So that's one demo, and then I want to show you this other one that I have. So this is a more complex game. So it's the same thing, but with a different game. So this is a platformer. All the assets come from this page called Kenny's Assets. I have the URL in the slides as well. So let's see how this looks like. So in this case, it's again same thing. We have a game, but now we have more modules, right? So the game is more complicated. But you see, we're importing other modules, right? So in here, for example, we have an enemies, and we have a tiles file, right? So it doesn't matter what we change, right? So this is basically a platformer, as you would like Mario. But the idea is, if I go to any of the files, let's say I have my tiles here, right? So the zeros are, let me make this bigger. The zeros are empty tiles, ones are grass tiles, right? So if I start changing my code, you see the changes are immediate, right? Because the engine just detects a code change, and then it just reinterprets that. It doesn't matter that the change is in a file that is imported by the main game file, right? Because as we said before, since we use esbuild to build a bundle, it doesn't care. esbuild is going to resolve all these imports and then just serve a single file, right? So that's what you got, right? And now you can like test it. So imagine that you're building a game and you're like, oh my God, this is not enough. I cannot reach these ledge, right? So I did a very bad decision there. So what do we do? Let's change. So we have a long jump speed. So let's make this a bit higher. So what happens? Oh, okay, now it's too much. But you see, the change is immediate, right? And this is what I was referring to as the feedback loop. And now let me show you actually what I was saying about the recording the input, right? So I have this function. Again, this is another great thing about using the web. All of this is HTML, and you didn't have to create like a UI engine or anything, right? So I can record the keys that are pressed. So let's say I do this, and then I can play them back. So what's happening is the engine is calling my draw game. Well, we call them my draw function, right? As we showed before, there's a draw function, and it's being called with an input, right? But the engine is not telling you the input comes from the user, right? In this case, the input comes from a recording I just did, right? So what's the cool thing about this? Since your draw function doesn't care about whether the input comes from one place or another, nothing has really changed. I can come here and say like, okay, so let's say I change my long jump speed to 1300. So you see, the change is immediate, right? And I don't need to play the game, right? The game is being played. So what if I say to 1200? Not enough, right? So okay, so 1300 seems to be the sweet spot, right? And that's one of the cool things that you can get when you get the engine in place, right? And I mean, this would give for another talk, but there's some concepts in functional programming, right, where you separate the state from the logic that I have applied a lot in the game, right? Because if your logic does not have the state inside, you can do cool things like this, right? The state comes from the outside. Your logic is oblivious to the external state. Okay, so what else can you do? So, what I was saying before about playing frame by frame, that's a very cool thing. So now I'm playing exactly the same trace of input that I had before, but I'm hitting right, because the engine, what it does is it hopefully interprets that as go to the next frame. Yeah, there you go. So you see, I can execute one frame on demand, right? And now if, for example, I wanted to, let's say I have a bug in my collision detection, right? So I can always use the developer tools, right? And now the game is stuck in that frame. So I could come into the source code. It's too big. And I could say, okay, so let's go to my implementation of collisions. I know, it could be anything, right? But I could say, so let's see the part where I check for a collision app. Okay, so I put a breakpoint there, and then I go to the next frame. So this is not being called. Let's try with a different one. This one should be called. So for some reason, it's not stopping. Let's try again. So I start recording. Oh, now it stops in there. Yeah, but I don't care now. So I record, right? We run something, then we do frame by frame. And then when you are at the point where things should matter, right? Where you care about the code, right? Then you set the breakpoint, and now it stopped, right? So now we're stopped in the middle of a frame that maybe there was a collision just in that frame. We wanted to know what was happening. So now we're in the debugger mode, and we can go like F10 usually. I don't know in Chrome, but you can like go line by line, see what the values of your variables are. So this is very powerful, right? Because you have complete control over the state of the game and the logic, right? So you could like debug at the exact frame where you care about things, right? So I'm not going to make this longer because we have like 5 more minutes, and I want to leave some time for questions if we have them. But yeah, that is the demo of what you can do with this. And again, this is not the purpose of this was not to build a full-fledged demo. It was, I mean, not a full-fledged engine that anyone can use. It was more to kind of prove some points in how you can build quite easily. I mean, there's some moving parts, but the technologies are already there, right? And build this kind of engine. So yeah, if there's any questions, I'll be happy to answer them. I'm looking at the comments, and thank you everyone. I left some links here in case you're interested to the code and also to some resources I used.
We'll share those on the comments. Thanks, David. This is pretty cool. I'm pretty impressed with the responsiveness of both the game and the hot module reload, actually.
Yeah, I mean, there is also a whole discussion about responsiveness and performance, because as you probably know, so JavaScript has some design decisions that may not make it the best for some types of games, right? Like being like dynamically allocated, like you have this garbage collector, and also when you have the engine enabled, there's a lot of additional code that's running behind the scenes, right? These automatic imports, maintaining the state from a frame to the next. I do a lot of code that is not very performance, that is not great for performance. But the idea is you would use something like this while you're developing the game, and then once you're good with the result, then you would take your code out of the engine, right? Or disable all the hot reload parts and run it with a bit better performance.
And so is ESBuild what is it Vite or Vite? I don't know. Or
so yeah. So ESBuild is an implementation of a bundler that is purely written in Go. And that's why it's so fast. It's just a binary. You run it. It doesn't run any JavaScript, although the main thing it does is parse JavaScript code. But it's all Go. It's written, I believe, by one of the engineers on the Safari team, so he knows what he's doing. And Vite or Vite or Snowpack, I believe most of those use ESBuild under the hood to give that automatic reload.
Oh, that's pretty cool. Okay.
It's a very cool project, and it's very easy to use. If you want to if your project for some reason needs to bundle JavaScript, you can call it as a function, and it does everything for you.
And do you know, maybe you don't know, but do you know what are the things that ESBuild doesn't have that Webpack does have?
Yeah, so I believe ESBuild, and now I may be talking without knowing. So take this with a grain of salt. I believe, so they have things like, for example, TypeScript support. So they can bundle your TypeScript, but they don't do the type checking, right? Because that's very time consuming. And I believe that all these other plugins that you can add to Webpack, I don't believe those work on ESBuild. Like I believe I read something that they support some plugin interface, but I'm not 100% sure.
Oh, that makes sense. Cool. Well, I don't have any more questions. I don't know, Urbano, if you have any questions or if anybody has any questions that they'd like to drop in the comments.
And you said Kenny was where you got the sprites?
Yeah, that's a great asset. So it's called Kenny's Assets. If you go to his page, yeah, he's a guy from the Netherlands, and he does all these like super high quality assets for your games, and they are like totally free as in beer and free as in speech, right? So you can use them in your project. I think that he doesn't even ask for attribution. He's like so nice. He puts all these things. He has a Patreon, so if you're writing a game with his assets, it would be good to support him. But yeah, he has a lot of stuff there for things like demos and quick prototypes.
Yeah, he does have a lot of stuff here. So I was looking at it and I was like, that's cool how you got the sprites from this place.
Yeah. He released a new isometric tiles for a town that look really cool.
David, will you make these slides available anywhere?
Yeah, I'm gonna upload them. I mean, we'll work on uploading them. They're in Google Slides, but we'll generate a PDF or something. And the code you can access in GitHub. Again, it's not production level by any means. I try to document things, but yeah, use at your own risk, as they say.
Cool. Do you know? Have you seen that game? You know, when you go offline, there's like this little dinosaur game on Chrome. Do you know that do they use like Canvas and stuff? I'm assuming they do, but
that's a good question. Yeah, I don't know. I mean, Google does have a lot of resources to build that in OpenGL if they want, I guess. I actually don't know what they use. So yeah.
All right. Cool. Well, I think unless there's any other questions, we can say thank you, David, and have a good night.
Yeah, thanks everyone for coming, and contact us. We're always looking for more speakers, so you have an idea for Miami JS talks. We're always open to hearing them.
All right. See you guys next month.
Thank you. Bye.
Bye.